of you. In the last class, we had an introduction here, filtering. Filtering means you are changing some parts of the image by doing something or the other. When the function is a linear, we call it as linear filtering. And in linear filtering, we saw two types, correlation and convolution. I believe that you would have understood how to sharpen an image, how to blur an image and so on, right? These were the things that we have studied in the last class. Today we'll see another two important types of non-linear filtering. Linear filtering means you have a linear relationship between the, see, all these things are converted into equations, right? We'll work on that. I have shown you examples in the lab session in the last class on how to crop the image, how to load and so on, right? I have only taught you certain commands, and when you run the commands, you get some output. That's it. But I believe that you don't know how these commands are working. If I say cv.im read underscore grayscale, you are having a color image that is converted into a grayscale image. That all of you know. But how does this work? That you don't know. We learn that stage by stage. I believe that all of you are very curious and all of you are very much interested in learning more about this particular subject. I do not know about the other subjects, but this subject I believe that is of interest to each and every student, whoever is here. That's my confidence. So here what we'll be doing in this lecture session is that we'll be learning two types of filtering. One called as median filtering, the other one is called as bilateral filtering. Okay. These two types of filters are non-linear filters. Clear? There will be a mathematically, there will be a linear relationship between the converted image and the original image in case of linear filtering. In case of non-linear filtering, the things will be different. I'll teach you what it is. And if you have any queries, you are always free to stop me at any moment and ask me any questions. So let me introduce to you filters we have looked so far, all have been linear. So we have looked, or we have really understood two types of linear filters, convolution operation and correlation operation, in which you are going to blur an image or sharpen an image and so on. That means the response to a sum of two signals is same as the sum of individual responses. Okay, that means when do you say that a function is linear? You have two functions, f of x and g of x. You have a linear relationship. What do? Alpha into f of x plus beta into f of x should be equal to alpha f of x plus beta f of x. I'll just write this and show you. A linear function, for example, f of alpha x plus f of beta x will be equal to alpha f of x plus beta f of x. This is a simple explanation for a linear function. We'll study in detail what linear functions are. But anyway, we have completed our linear portion. Now what we are going to do is, we are going to work with non-linear operators. So, the sum of the two signals is same as the sum of individual responses. We have some drawbacks in linear filtering. These drawbacks can be overcome in non-linear filtering. We can see how we are going to overcome this drawbacks and what is the advantage of using a linear, a non-linear filter. See, these slides will be shared, and this is also most of my lectures, not everything, at least most of them are posted in YouTube. If at all you are missing any of these things, you can go and refer there. If you are absent also, you can go and refer there. And for your exams also, you can use these kind of tools. So if you have not completed in any case and you wanted to have something remaining, that you can make it up in the next. Or so I told you today we are looking into two types of filtering. The first one is called as median filtering, where the output pixel is a median value of the pixels in its neighborhood. Very simple. You are converting these into a matrix. Now each and every pixel is being taken, it is having a value. This numerical value is taken out, and the median of all its neighboring values, it is getting replaced, and like that entire pixel is being replaced. You are doing median filtering. In median filtering, every pixel is replaced by the median of its neighbors. Median of its neighbors. The most important advantage is that median filtering is very effective in removing salt, short noise, or what you call salt and pepper noise, or some things like grains. I'll show you this with example images in the coming slides. You can make a note of this for the time being. I'll show you some examples of images after doing this median filtering and before median filtering. The most common filters, whatever we have seen, is the Gaussian filter, right? We'll take Gaussian filters as standard for almost all kinds of our study. So here, blurring of edges is being avoided in median filtering, unlike this Gaussian filter. For every of our filtering techniques, for every of our uh, experiments, we'll try to standardize the Gaussian type of filters. Okay, so we'll be using Gaussian filter and we'll compare the Gaussian filter with the other types of filters. So this is what I meant by that salt and pepper noise or the short noise. So you want to remove this kind of grains in your image. The easiest and the best way is that you take the median of all the neighboring pixels and replace that pixel with its median value. In that case, you will get this output as this kind of image. This image I have taken from Wikipedia, and the source is given in this slide. You can go and search in Wikipedia and learn more about short noises, salt and pepper noises. Okay, and what happens when why it is occurring and so on. You can have more understanding about these kind of noises when you start learning more. Okay, I wish you go more into that and learn deep about that. Okay, so here is what it happens. This is the original image. First time in median filtering, you get this kind of first First layer, that is one time median filtering. Second time, two time median filtering, three, and so on. Like that, if you make it in 10 times, you get a completely blurred image. You can see that this and this, you have some removal of grains and so on, right? Yes. So we have seen the advantages of median filtering. So what are the disadvantages? Median filters are implemented. Here I have mentioned only two disadvantages of median filtering. You have multiple disadvantages. You have multiple disadvantages of median filtering. Okay. See, we have seen an image where we have first stage, second stage, and 10th stage. As the number of stages go, you find that there is the rounding of sharp edges. Okay, this is one of the disadvantage. I showed you an image right in the previous slides where we are having multi-stage median filters. So the basic disadvantage is that you get some, each stage you get some rounding up of sharp edges or corners. So these are the major disadvantages. We have some more points which, see, disadvantages is always an area where you can improvise it. Mathematically, what you can do so that you can avoid the rounding of sharp corners. What is the disadvantage with the median filter? You can study and analyze. So here is where, see this part, you don't need to see. I will just cut this off. This part is not required now because this is the next topic, bilateral filtering. So this is how median filtering is done. You have two types. You have a variant in median filtering which is called as alpha mean, where you have some kind of changes with the calculation of the median. Okay, so this is the basic median filter where every pixel is replaced by the neighborhood median of its neighborhood values. Next important type of filtering is called as bilateral filtering. So we know that we are looking into bilateral filtering. We know that we are looking into nonlinear filters. So in median filtering, we have seen that we are unable to preserve the edges. So here, bilateral, we are trying to overcome this kind of disadvantage, and this reduces noise while keeping strong boundaries, and it increases the sharpness also. As I told you, for every purpose, we compare it with our Gaussian filters. Okay. So when compared with Gaussian filters, what happens is that the spatial distance between the filters, in bilateral filtering, we consider both the geometric and photometric similarity. So this is a briefing about what bilateral filtering is going to do, but how it is going to do, the output pixel value depends upon a weighted combination of neighboring pixel values. So how are we going to bilaterally filter this image? We are going to take the weighted combination of neighboring pixel values. We have multiple formulas. If you have to learn in depth, maybe it is going to take so much of time and beyond the scope of our study. So as much as possible from our end, we'll study that. Okay. So in this same image, what we are going to do is that we are going to remove this. This one we have already seen. This is median filtering. So this part is bilateral filtering. You should understand that you have two types. One is called as domain and the other one is range. Domain filter and range filter. Okay. So in both these things, we are doing some games with these numbers in the matrix and we are going to change or replace certain values. So here, this shows what happens to an image after a domain filtering is being done, and this C shows us what happens after range filtering is done. See, the name of these filters itself will give you a clue about how it is going to work. Okay. In bilateral filtering, we have two things, one called as domain kernel, domain filtering, and then range filtering. And what we do, we multiply the output of domain filter with the range filter to get the bilateral filter output. Okay. So what is done in domain kernel? Okay, weights, pixels are based on their spatial distance from the central or the center pixel. This happens, this creates a kind of standard blurring. Now I am explaining to you the working principle or how bilateral filters are being used or how to create bilaterally filtered images. So two types you have. First one is the domain kernel and the second one is the range kernel. The output of the product of both these things will be the output of bilateral filtering. Two types, domain kernel and range kernel. In domain kernel, weight pixels are based on their physical distance or spatial distance from the center pixel. In range, weight pixels are based on how similar is their intensity or color to the central pixel. So you are taking every pixel, that pixel is called as the center pixel. You are comparing it with all the neighborhood. This is what is called as neighborhood operations, right? In first case, you are seeing the distance between the center pixel and the other pixels around it. And the second case, what you're going to do is that you're going to compare how common it is, how these values are very associated, right? If, for example, you take an image, if you have a background, certain area will be fully the same thing. There won't be any change in the values, right? So these are all similarities in intensity and other aspects of the image. So what are the advantages of bilateral filtering? It's all pure theoretical and academic. You need to write whenever a question is asked about what are the advantages of bilateral filtering. It preserves the edges. This advantage is prominent because you have median filtering which does not do this. So an advantage of bilateral filtering, if you study, you can understand, or you can write the disadvantage of a median filter, right? Does not preserve the edges. More simple. Perceptual quality. The images are more softened, or you have softer outcomes. You know why? Because we are using two types, the range kernel and the domain kernel. In range kernel, we are comparing the similarity in color or intensity value with the other neighboring pixels. So this is the advantage, and this is why we have better quality images coming out of bilateral filtering. In our lab sessions, I will be teaching you how to do this bilateral filtering. The theoretical aspects, I believe that you have to understand, and exactly how all these things are done stage by stage, we can study in the case studies or in the coming lectures. I believe all of you have noted this down. Shall I go to the next one? Disadvantages of bilateral filtering. Higher computational cost, because you have two things, Instead of doing, you have to find out the domain kernel, you have to find out the range kernel, you have to calculate the similarity between the pixels and a center pixel for range kernel. For domain kernel, you need to know about the spatial distance from the center pixel. So you have computational cost has naturally increased to a great extent. Then what happens is that the salt and pepper or the short noise removal is not possible or is very difficult in bilateral filtering. Corner rounding, like many other smoothing operations, you can see that you have some rounding off or some blurring in the sharp edges that is being sharp. So today I have taught you two types of non-linear filters, median filter and bilateral filter. I've shown you some examples also. I've made you understand what is median filter and I made you understand what is bilateral filtering. To this extent, I believe that all of you would have understood what is median filter and what is bilateral filter. Is there any questions that you need to ask me? How many of you really understood how this process is being done? How many of you can answer my questions if I'm asking you some questions? I want my sessions to be more interactive. Okay. So thank you all. Thank you for listening to me.